American Airlines flights from Denver to Atlanta are on time 50% of the time. Suppose 8 flights are randomly selected and the number on-time flights is recorded. The probability that at least 2 flights are on time is what? Okay, so anytime we have a probability problem to answer, we have a lot of different methods to use to solve those. But if we take some observances of our situation, it might be the case that we can use a distribution to solve it. And distributions are nice because they're very systematic ways of getting probabilities. One clue here is that we're looking at flights being on time. So either the flight is on time or it's not on time. There's only 2 outcomes here. So that is a good hint toward a binomial distribution. What we also need to make sure of is that we have a fixed number of trials. So we have a group of 8 flights. So that's our fixed number of trials. And then we need to know that each trial is independent of the other. And if one flight's on time, it's not really going to affect the probability that the next flight is on time. So we can assume independence. Now, using binomial distributions. First off, we want the probability that at least 2 flights out of the 8 are on time. The most important aspects are n and p. So n in this case is the 8 flights. P is the probability of success, which is 0.5. Now we want the probability of at least 2 flights out of the 8. So at least 2, that means that the number of observances that we would like to see is greater than or equal to 2. Because that's what at least 2 means. It's 2 or more. So for at least 2, what we're going to have to do here is use Binomcdf. But we use Binomcdf in a rather tricky way in this case. So let me show you the full binomial distribution to help you understand exactly what we need to do. Okay, here's our binomial distribution, and the blue shaded region is the sum of the probabilities I want to come up with. The height of each bar represents the output from the function Binompdf. So for instance, the probability that x is equal to 0 is 0.39, so this bar is, 0.0039, so this bar is very short, 0.0039. The next one is 0.0313, so this bar is set to a height of 0.0313. So each of these bars represents a height according to Binompdf. Now, I have also shaded in blue the region that we want to calculate. So this would be out of 8 trials, this would be at least 2, which would be 2 or more. If we added up all of those, this is the probability we're going to get, but we need to find a means of determining that. Because the problem is the distribution doesn't have, or rather the calculator doesn't have any means of allowing us to type in a lower bound and an upper bound as this program does. So we have to use what we have available, which is Binompdf and Binomcdf. Now, Binompdf gives us the probability of individual outcomes. We certainly could use Binompdf for x equals 2, x equals 3, x equals 4, all the way up to 8 and add those results together. But that's going to take a while. Binomcdf already does a sum for us. So Binomcdf takes the probability as a running total. So at x equals 0, that running total is just 0.0039. But if I add 0.0313 to that, it gives me 0.0352. And if I continue adding these together, that's what Binomcdf does for us. So the problem there is that it always starts the counting with 0. So That's the white boxes here, however. If we were to get the sum of these first two white boxes, we could use a complement to give us the blue boxes. So this is called a probability to the left, and that's what Binomcdf does. It always gives us a probability to the left of a certain number of outcomes. To change it to the right, we just have to use a complement. So what I'm going to do is use Binomcdf. Its inputs, we need 3 of them. N and P are the first 2, then X is the last one. So N is going to be 8, P is 0.5, and X, what we're going to use for X is we're coming up with the white boxes, so the white histogram bars, and those stopped at 1. So if you think about this, for at least 2, the outcomes that we would have here would be 2 to 8. So I want to do the computation for 0 and 1, which is the complement of 2 to 8, and then subtract that result from 1. So the answer here is going to be the sum from 2 to 8. So let's give it a try. If I take 1 minus, second in bars there, and scroll down to Binompdf, then Binomcdf is right after that, and N is 8, P is 0.5, X is 1. That gives me 0.9648, which is exactly what the sum of those blue bars was. 2, the probability that at most 3 flights are on time. So at most 3, we just have to decide what this is going to look like. So out of 8, at most 3, that's going to be less than 3, so we're going to go from 0 to 3. We would include the 3 because it's saying at most 3. All right, so that is inclusive. So there's still 8 trials. Probability of success is still 0.5. But I want to get the sum of the probabilities for 0 flights on time, 1 flight on time, 2 flight on time, and 3 flights on time. Instead of doing all of those indirectly and adding together using Binompdf, I'm going to use Binomcdf. N is 8, P is 0.5, and X is going to be 3. Now, I don't need to do a complement because when I'm going from 0 to 3, the shaded bars here in blue, these are left-hand probabilities. So it's already to the left. So all I need to do is just give 3 as an input to Binomcdf. And if you'll notice, that agrees with this probability up here. So if I do that on the calculator, so you can see it, distribution menu, come down to Binomcdf here, 8, 0.5, 3. We get 0.3633. The probability that exactly 2 flights are on time. Exactly 2 flights out of 8. That wording that there's only a single outcome that you're interested in. That's the time where you get to use Binompdf. The first 2 inputs are always the same, N and P. The last input, which is X, that in this case is going to be 2 because we just want the probability of exactly 2. Scroll down in the distributions menu till we find Binompdf, 8, 0.5, and 2. So 0.1094.